We're going to integrate x squared over 3 plus 4x minus 4x squared to the 3/2 power. And just remember that the 3/2 power is the square root of that expression to the third power. Now, this one is going to require a trig substitution, but before we can do that, we're going to have to complete the square. So we have 3 plus 4x minus 4x squared, and we're going to have to write that so it looks like one of the forms that we want. After we complete the square, it will either fit into a squared minus x squared, a squared plus x squared, or x squared minus a squared. These are just the generic terms. Clearly, the x will be replaced with a parentheses. To complete the square, I'm going to rewrite this as negative 4x squared plus 4x plus 3. And completing the square, we want x squared by itself. So I factor out a negative 4, and I have x squared, negative 4 into positive 4x, negative x plus 3. Completing the square, the coefficient here is negative 1, so I have negative a half, and when I square that, that is positive a fourth. So I add positive a fourth. But I really, by putting a 1/4 there, it's negative 4 times that is a negative 1, so to compensate, I'm going to add 1. I can now write this as negative 4 times x minus a half squared plus 4, which I now can reverse and put the positive 4 first, and it's 4 minus 4 x minus a half squared. I have now completed the square. So we can now write 3 and 4x minus 4x squared is 4 minus 4 times x minus a half squared, which is going to fit into this top form. So I am going to factor out a 4 because I like to have a 1, and I get 1 minus x minus a half squared. And this is 4 times 1 minus sine squared theta, which will be 4 cosine squared theta. We're now ready to do the key for this. Looking at this, we can see that x minus a half squared is going to be equated with sine squared. We make the quantity x minus a half squared. That's going to be sine squared theta. So sine is just x minus a half is sine. And once we have that, we right away can do the triangle. So putting the triangle, here's theta. This is x minus a half over 1. It's opposite x minus a half over hypotenuse 1. And sure enough, going through this, we're going to put these together. Using the Pythagorean, this becomes the square root of 1 minus x minus a half squared. Next step is we're going to get x equals. X is sine theta plus a half, and now we're ready to get dx, which is the derivative of sine is cosine theta plus the derivative of a half is 0, so it's cosine theta d theta. We now have most of everything that we need. Putting the integral again so you can see, we're doing the integral of x squared over 3 plus 4x minus 4x squared to the 3/2 dx. I'm now ready to do my substituting. For x, I'm going to put sine theta plus a half squared. Dx is cosine theta d theta. Now the Parentheses was 4 cosine squared, but it's to the 3/2 power, so it's square root of 4 cosine squared theta cubed. Continuing to do this, I'm going to just change square root of 4 cosine squared is 2 cosine. So this is sine theta plus a half. We've got a cosine, and this was squared, a cosine theta, and then here we have 8 cosine cubed theta. I can work the numbers, but certainly here this cancels and I have a cosine squared. I'm now going to write out the whole numerator by foiling that binomial sine theta plus a half. What we get is we get sine squared theta. We've got a half sine and another half sine is a full sine, and we've got a half squared is a fourth. And then we had an 8 here, so we have 1/8, and this is all being divided by cosine squared theta d theta. Now we have all of this 3 terms over cosine squared. The best approach at this point is to separate everything. So we have 1/8 the integral of sine squared over cosine squared. Then we have sine over cosine squared, and 1/4 over cosine squared, which is really, at this point, I know 1 over cosine squared is secant squared, so I'm going to write it as 1/4 secant squared theta, which gives a hint as to what we're going to be doing with the rest of them. Now I'm going to write these and write them so you can see what we're going to be doing. I'll go to the next page for a minute. We have 1/8 the integral of sine theta over cosine theta. That'll be squared. We have sine over cosine times 1 over cosine. And then we've got 1/4 secant squared theta d theta. We made that last switch. We can now rewrite these as 1/8 the integral of tangent squared theta. This is a tangent times secant, so I'll write it secant tangent, and 1/4 secant squared theta, all of that d theta. This one, we know these last two, but if I change this, this becomes a secant squared minus 1. I have an antiderivative I know the answer to. Working this through, I have 1/8. The antiderivative of this secant squared is tangent. The antiderivative of 1, negative 1, would be negative theta. The antiderivative of secant tangent is secant. And the antiderivative of 1/4 secant squared is 1/4 tangent. I can put these two together. So this is 1/8 5/4 tangent theta minus theta plus secant theta. Now we're ready to go back to the triangle. So I'll move us back and we'll put the triangle again. This triangle is going to give us the information we need to complete the problem. And the triangle had a side opposite of x minus a half. The hypotenuse was 1, and then we got the square root from the Pythagorean. Putting the triangle, we have with theta, this was x minus a half, this was 1, and this was the square root of 1 minus x minus a half squared. We're now ready to use the triangle to put in tangent and secant. And of course we know this triangle came from the fact that x minus a half was sine of theta. That was the original that gave us the triangle. I'm ready to almost complete this, so I have 1/8. I have 5/4. Tangent is opposite, x minus a half, over adjacent, which is square root of 1 minus x minus a half squared. Then we have to get theta, and we get theta by undoing sine theta. So we have inverse sine x minus a half. And now secant is hypotenuse over adjacent. So we have 1 over the adjacent is square root of 1 minus x minus a half squared. And of course, this is plus c. So without simplifying, we've got the first of the answer steps. I'll go through steps. Clearly, to get this simplified, first I'm going to work under here. The square root of 1 minus x minus a half squared is the square root of 1 minus x squared minus x plus a fourth, which becomes the square root of 3/4 minus a minus plus x minus x squared. So I can simplify the square root that way. Right away in red, I'm going to write the next step. So we have 1/8 5x minus a half over 4 the square root of 3/4 plus x minus x squared minus inverse sine x minus a half plus 1 over square root of 3/4 plus x minus x squared plus c. But with complex fractions, we want to get rid of this half. So I'm going to multiply top and bottom by 2. I'm going to put a 2 here. And even though I have a complex fraction here, which is going to be all of this over square root of 4 is 2, I'm going to multiply top and bottom here by 2. So this now becomes 1/8. I have the 2 going through, so it's 5 times 2x minus 1. This green 2 going through here, it's 4 times the square root of, it's putting a square root of 4 here. So it's 3 plus 4x minus 4x squared minus inverse sine x minus a half. And now I have 2 over, the square root of 2 becomes a square root of 4, which gets rid of this, and it becomes square root of 3 plus 4 times that, 4x minus 4x squared. So working this, we have 1/8. 5 gets distributed through, and it's 10x minus 5 over 4 of these radicals. We have negative inverse sine x minus a half. And now I would like a common denominator. So I'm going to put a 4 radical as the common denominator. That's going to require a 4 top and bottom. So I get 8 over 4 radical 3 plus 4x minus 4x squared. And all of that plus the constant. We're almost there, you guys. We're just going to combine like terms. This gives us 1/8. We put 10x minus 5 plus 8, and we get 10x plus 3 over 4 radical. And we have the negative inverse sine x minus a half. And of course, if we wanted, we could distribute the 8 in the denominators. Take the 1/8 through. That's our answer.